After one inspiring talk, it's time for the another one. Our speaker is Professor Saptarshi Majumdar. He's a professor in Department of Chemical Engineering at IIT Hyderabad and currently the Dean Academics at IITH. His research interest is in the area of multi-scale modeling, biomaterials design, industrial process analysis, molecular simulation, mesoscale thermodynamics, drug delivery systems. He has 20 plus years of experience, including 10 plus years of industrial R&D. Now I request Professor Saptarshi to deliver an inspiring talk to our researchers. Welcome, sir.
Thank you very much. Is it audible to all of you?
Yes, sir.
And screen is visible?
Yes, sir.
Yeah. So thank you very much for the introductions. And I don't know whether it will be inspiring or not, because the problem of the administrators are that they hardly find any time for anything. Okay. So yesterday I tried to make the slides ready for today, but then the semester is coming to an end, and since last few days I don't have any time for even sleep. So that's the problem actually. Since morning I'm continuously working and straight from bed, and even academic secretary called me, and I told please call me after 15 minutes because I am yet to even brush. So situation is such a bad. Anyhow, so no problem. So because COVID situation has put all of us in a bad shape, and thanks all the PhD doctoral representative and all of you that too in this situation also you are maintaining a positivity, and that positivity is very important in our life. As you know that the situation is so bad around us, so we cannot be negative, because negativity will just make you finish. So thank you very much. So this lecture, what doctoral representative told me that I should be giving in a very the lecture should be given in a very, what should I say, very generic level, because the variety of people are there from across many departments. See, the thing is that this is very important. I am from industry. I have spent close to 11 years, and I'm plus to industry, and I'm close to 11 years in academics. So I'm just still on the half point. After 6 months down the line, I will be academician. Till that point, I am a hybrid situation. So industry, the presentation is very, very important. This does not matter how much you know, how much other people are receiving. That's important. So many times we academicians, we don't give that much importance to this idea that how much others are receiving me. So that, but in industry, this is very important. Give an example. We usually used to coin. There's a management training to us, and presentation was given like this way: that you assume a case that you are with a CEO of the company who cannot afford time. Okay, so you are coming down from a building of say 30 floors, and in the lift you are with the CEO. So in that 2 minutes time or 3 minutes time, you have to give your idea. You have to tell that what you need to do. You have to convince him. Okay. So think about the difficulty, that within 3 minutes, how much precise you should be, so that the CEO will be understanding your entire idea. Anyway, so today let me try with this backdrop that can you so that I can penetrate to some extent to all of you. Anyhow, so I work in many other places. This work, what I'm presenting to you, it's one of the work, but I have chosen this work. As I mentioned, there are several interesting work to me, but then I felt that I need to give something which is much more understandable by many people. So I have taken a work which right now also we are doing, but we completed the major part of work only till last year. And there are two projects, one from DST Technology Development Scheme, another is presently going on with CSIR, along with my colleague, Dr. Dept, and Deepak is the student, he is the student who has already graduated right now, postdocs. So, what is happening? Yeah. So I am from, my lab name is Polynanobio in chemical engineering departments. So I work in the multi-scale design of biomaterials. Basically, I work in polymer, you can say. I am a consultant to Tata Steel. There I work with coal. Coal has a polymer, and I work with my colleagues at Dr. Lopamudra in cellular biology, where protein is a polymer. So think about if you are understanding fundamentally, and my main USP is thermodynamics. I am a student of thermodynamics, and I try to, for me, that does not matter whether I'm applying things for industry like Tata Steel, where it is an industrial process, is a how you are utilizing coal, the rejected coal to get the carbon materials, and where same thing I'm doing here, another polymer is a protein, which is swimming in the cytoplasm and can in response to a drug molecule. So basically, I'm working on polymer and thermodynamics and doing engineering with that. So through simulations, through experiment, and it's a multi-scale engineering for me. Just to start with my things, let me ask if any of you can tell me that, according to you, what is the most impactful equipment of the earth? If anybody can say, I'm giving you a couple of answers, which usually people give it to me. One is a computer, another is a mobile phone. Okay. So these are the most impactful things people say. Okay. Frankly speaking, I don't need any of these to run my world. Frankly speaking, see, 60 years, 50 years back, world is that time also civilized. Okay, we are more advanced now, I understand. But to run the world, 60 years back, we were running the world without these two. Okay, and it was pretty good. The advancement, if you see scientific advancement, was taken a peak around 1900, first 50 years. So that time the scientific innovations, inventions, discoveries are at the maximum. So it went up to 1970, 75, and then you see it is steady. After that, it is not very new discoveries are coming, fundamental science and technology. After that, there's incremental benefit, and then of course we are running the show. So it is not that we need to run. That time also we were running the show, and these are very important thing. But I'm not saying that these are there is a competition. But frankly speaking, the equipment I am going to show you, this is heart of a refinery. And then you can say that whether can I tell this is the most impactful equipment of the earth. This is the distillation column. Okay, you are using the crude oil. Give me an example. I'm getting from Middle East. I'm getting from Middle East or Bombay High or Digboy or any other places. I'm getting the Middle East, doing the pre-processing, putting in the things. It's a refinery. Indian Oil Corporation, Reliance, ExxonMobil. So name the many companies in the Fortune first 20, first 10 companies. They are basically oil companies, and because of oil only, you see the Iraq war, the many other Middle East conflicts. Everything is going on because of this importance of the oil. Okay, so you see that importance. You do a distillation where you are separating this crude oil. This crude oil is a natural product which is having so many things around it. You need to separate this with the valuable things for the society. What is happening on the top? The gas is coming to your kitchen, LPG. This is the LPG. It goes to a bottling plant where you bottle it and you make it LPG. So top we are getting the cooking gas. Here I am getting the fine chemicals. Whatever chemicals you are seeing, like pharmaceutical, every medicine, whatever medicines you are getting, most of the feedstocks are coming out of these chemicals. Then fine chemicals, resins, every product you are touching, the being textile to something, there are certain chemicals coming out of it. Then it is giving the gasoline, which is running your cars. Then it is giving the aviation turbine fuel. Okay, so basically that is all the aircrafts are moving through this. Then the diesel oil, all the locomotives will be moving through the things. Now it is lubricating oil. No machine will work if this lubricating oil will not be there. If there is no machine, our Sukhois will not fly. Our Rafale will not fly. Even if Rafale is a fantastic machine, will not fly. No machine will work if you don't give the lubricating oils. And then we get a fuel oil which gives all the big ships, cargoes, and plant. They are generating heats for which through this. And this is important. What is the excreta? That excreta, it coming out as your infrastructure development. The road, the asbestos, everything comes out of it. But think about a single equipment which is processing the crude oil as having the kind of things. We cannot say everything without this civilization can run. And by the way, this we are running right now. We are doing computer control. These are much more precise to nowadays. We have a fantastic control on that. You may get a smell of petrol in a petrol pump, but you will not get a single smell of petrol if you go to a refinery, which is tackling probably 1 lakh times more capacity than any largest petrol pump per day. Still, you will not get a smell, such a precision. So, of course, precision will be lost. But we can run the show by this, that we have already done for the last 100 years, more than that. This is the one most important equipment, most impactful equipment, if you ask me, compared to the range of products that is having. And every day we are having, and so many industries down the line are waiting for it. Give an example, the fine chemical, these chemicals, entire petroleum industries, entire Reliance company will be waiting for it. So it's a huge impact for the society if single equipment goes. Okay. But problem is, what is the problem? Why I'm starting with this? What is the research? Problem is this guy, crude oil. Yes, we are greedy. Human is very greedy. We never thought about you. My earlier generation never thought about us. We never thought about you. We are finishing it so fast that we don't care for our next generation. We are standing at the 4 p.m. of the day. We are now coming to an end. All the reserve, valuable reserve, science has only increased our greed, satisfied our greed. And right now this is coming to an end. What will happen to all this? What will happen to all these things which is a kingdom for us? Okay. So the thing is that there are a lot of alternatives being thought. See, the thing is that what are the alternatives? You are hearing many times say solar cell. Solar cell, fantastic research is going on. But the issue of solar cell is that efficiency is still down 13-14% industrially. And on the large scale, even if you take this, even if you cover the entire Earth, still probably the kind of energy requirement we have, we cannot meet it. That's a calculation already been known to us. So there are several things. I'm sure that next 20 years we will see a lot of breakthrough there. But as of now, the things are not showing that it can replace the things. Second important thing is that what about there's a huge, enormous reserve of gas, natural gas, but the natural gas is also a maximum 10 years. If we go for 10 years, 20 years, 30 years, if you go for the present consumption. What about fuel cell? Fuel cell also depends on a gas only, natural gas or something. Otherwise, if you don't give hydrogen, you don't reform hydrogen, fuel cell will not be working. Lithium ion, we don't have that much lithium. So people are now talking about sodium. And even in sodium, how many batteries you have? Think about if you run everything on batteries, those many batteries you have to dispose. Where you will dispose? Another problem will creep in. So the entire thing is so much complicated. In future, one thing is for sure that none of the single technology or energy source can give you everything. You can have lots of hydrothermal powers, but we all know now that huge hydrothermal powers reservoirs are creating a heavy risk of earthquakes because it is creating enormous pressure on the tectonic plates. So nothing is problem free. So but then, and none of this can feed the appetite of a car or of a aviation things. No battery can run this. You need simple fuel. As of now, the technology of batteries or whatever you have, solar cell, you forget about today, you have another 30 years after also, you cannot run this. The way it is, we are progressing, a full jet cannot be run by only batteries. The kind of, if you just extrapolate, impossible. So what the technology will be hybrid. So your appetite will be satisfied by the oil, but rest of the operation can be done by the batteries. So we call it hybrid cars. So the fuel efficiency increases from, say, if you have a hybrid car right now, if you take a normal car and a hybrid car, fuel efficiency is minimum 50% more. So that's the way we are going ahead. All the technologies are important. I'm not at all saying that those are bad. Everything is important now. So all the research should come together and make it through and make it happen. But unfortunately, this guy is coming down. So we need to replace it by something similar to it. Battery cannot replace it. We need to replace with something like this. What is that something? World have asked long time. We figured out that that this is the situation of oil, gas, and they're all coming to an end. Coal is there, but then coal has many other issues. Carbon dioxide emission is one of them. Huge amount of greenhouse gas comes out. Coal. So basically, all these alternatives are there, but there are no way you will be able to even 10% or 20% replacement of what petroleum is giving you today. 80% of world's today's demand is been met by petroleum. So now the situation is that this is the alternative what people felt. Lignocellulosic biomass. This is the alternative people felt to replace the crude oil. Okay, and you will be amazed to know India is planning 100 such plant in next 2 decades. They will be coming. But what is the lignocellulosic biomass? It is nothing but the residues of agriculture, forest, and you can do certain kind of cropping, which will be seasonal cropping. They will be giving certain kind of grass like switchgrass, willows, all these things, and you will be generating this kind of thing. And finally, these are environment friendly. Why? Because you are doing a crop for 1 year, you are extracting oil out of it, okay, and that oil is giving you carbon dioxide. Carbon dioxide is again trapped by the plants, and you are generating copper. So basically, the coal and petroleum problem is that the trapping of carbon happened billions of years ago. Millions of years ago, this trapping happened, and you are releasing it today directly on the things. So there is a delay in this. But in this, if you do a systematic cropping, what you can do, you can make it very well planned in such a way that you are doing cropping today. Next year, certain kind of oil being given, carbon dioxide is released. Similar way, the crops will be again absorbing. So you can make a cycle. You can make a cycle which is sustainable. So this is very important nowadays. Anything you do in engineering and science, sustainability has to be questioned. The environment has to put in. You have to give a tax for that. If you don't do this, your design will be invalid. So now this is the lignocellulosic things. What is happening? Cellulose and hemicellulose. Now the cellulose and hemicellulose, these two, they are giving you fuel. This is the fuel. So this technology is already done. We know how to do this. Right now, you give me 100 grams of lignocellulosic biomass, I will give you 50 grams of bioethanol. And you'll be amazed to know, right now our locomotives, already 10% of the bioethanol is being blended. It is no longer diesel purely. The diesel oil is blended with ethanol. Now all of our petrol pumps will soon have 10%. Then we are going for 20%. We will be blending ethanol. And we have already done the research that for mechanical engineering faculties who work in IC engines, that even IIT Hyderabad, Professor Raja Banerjee and all people, they work in this. They blended already the bioethanol and biobutanol. They have seen that IC engine can tackle. So basically this part is there. Then there's no problem. No, there is a problem. If you go back to the things, it is not only the fuel, but also if you need to really replace crude oil, you have to replace the chemicals also. Fuel is only one part. There are many things which are not fuel, like lubricating oil, like petrochemicals, from which the medicines and everything are coming. You need platform chemicals to make your medicines. Where from that will come? Fuel is not only the problem. Petroleum gives you, apart from fuel, so many other things. So many other 3 other important products it comes, and this one means n number of other products. Industries are depending on that. So there are a huge amount of things are there which you need the replacement for platform chemicals. And there lies the problem. There lies this technology is still not mature, because though we are replacing the fuel part, but the lignin, this part of it, it's a world natural most abundant aromatic polymer. This is rightly being burned out to generate energy. So world is thinking that can this lignin, we can generate certain kind of platform chemicals. So fuel part is developed, certain other products is partially developed. Okay, we need to generate the chemicals part of it for pharmaceuticals, for many other industries, so that that entire lignocellulosic biomass can be a viable technology to replace crude oil and can sustain the world for n number of time, because it is sustainable. If you make the crop, as I mentioned, with a proper systematic way, this cycle will continue and this will be nicely going at year after year. So this is the hurdle, this is the block, and everybody starting from US, Brazil, India, and many other countries who are having enough stocks for forest waste, crop waste, systematic crops, they are jumping at it, and starting from MIT, Stanford, everybody working in this, because this is the area where science has not been developed. technology is yet to be developed because science is not developed properly. Okay, so basically, here is the area where we try to do some work. Okay, so this is the lignin molecule. Very complicated polymers. Nature has never designed it for you so that you will be making it based on your convenience. So nature has never done this. What nature has done, nature has polymerized it for strength. Lignin is a strength part of the entire polymer. Okay, so now you need to cut it based on certain chemical scissor to make a smaller things depending on the bonds, and those will be the important thing. Now, how to cut it? There are several kind of things. Fortunately, there is a signature bond which is beta O4 bond. This kind of bonds, which is 46% to 40 to 60% in present in the thing. So we have to attack any development, any technology based on attacking that bond. So the problem is huge. The lignin is a collapsed polymer. Now think about if you want to open it to change to get the platform chemicals. If chain disrupts, you will get huge amount of free radicals and you will get plenty of products. You do not get one product. No, you are not getting one product because it is immediately giving you a devastating results. If you don't open, you are not getting. So if you open, then it's a problem. You are not getting a single product. If you don't open, you are not getting at all any product. So you need to be very careful about this. Now you have a very big molecule like lignin. In the same situation, you have a smaller molecule like this, which are platform chemicals you want. So in the environment, you need to stable both this and this. This is another challenge. Then all these things you have to do in a green solvent, because if you use a technology, as I mentioned, which is not environment friendly, it will not be lasting nowadays. So you have to think about a technology which is using only the green solvent, green chemicals, so that which can be replaced through natural means. Otherwise, design, if you don't put this in design, your entire engineering ideas will flop. So now we need to have so many challenges around us, and basically we made a benchmark. What was the benchmark before we started the work? Any research, you must do this. You first make a benchmark. That I learned from industry. Industry never works without making a benchmark. This is the benchmark I have. If anything more than that I do, that's a contribution. So make a benchmark to understand where you are standing. So it is a single benchmark out of the entire literature survey, based on which we did the work, and then the utopia to be achieved, neither fully open nor fully closed chains, still dissolved, stability of both large and small molecules, everything has to be done together, and that too with a economic way. That is a big difference between the science and technology. Science does not care what economics you are talking about, but the problem with engineers is that engineers will say there may be 10 scientific discoveries, but out of that only one is feasible because that is economically feasible. If that is not the case, it will not see the day of the light. So if economic part, if you don't put, it is gone. So you have to use a condition which is conducive, which is very mild and can be applied to the industry. Okay, so all these things we have started the PSDB project 3 years back. We developed the facilities in IIT Hyderabad, and at that time I was part of the DST committee also. So DST committee in Indian Oil and many other people who are there, they are all feeling this is a very important project to handle for the country's growth. So we want to achieve a huge lignin conversion with a selectivity. You need one product. You don't have 10. If you have 10 products, you have to separate them. You have to pay money for that. So you have to use a very high selectivity so that you can get one product out of it. So we use a molecular dynamic study by Stanford people, which shows that beta O4 bond is to be targeted, as I also mentioned to you. So what we have done, based on that, we make a drawing. And based on the drawing, we see if we go by this research, how the bonds are available and how they are getting clipped. Then what is the product that comes first? Then we saw very carefully that this is the product which is called glycol that comes as the first product. So now the problem is that why world was not getting? Because world was trying to get always certain product which is important for them, like these products, because they feel these are the platform chemicals. Now it is like Einstein's statement. You don't judge a fish its capability of climbing a tree. See, it is not possible to get it. Then we are expecting, of course, we cannot get a success. You must be rational enough which is coming out of this. So we figure, first thing we deviated from the world's thing. We figured out, no, it is not the other products. You can get only this. Then you can convert to other product. So our choice, attack of the problem was completely different than the rest of the world. We were trying to get what is more feasible. And another good part happened, as this is the first product coming in, our reaction time is only 2 hours. So within 2 hours of processing, we are getting an enormous amount of product. So you are saving the productivity, you are increasing the productivity, and at the same time, you are increasing one product selectivity, which is feasible. So that way we are completely different. Second thing is that we did lots of thermodynamic calculations. Thermodynamics is important part of the life. Many of you who knows, many of you who don't know. Let me tell you, everything I'm talking also, there is certain free energy minimization. Entire thing is world is happening because of 3 subjects: thermodynamics, quantum mechanics, statistical mechanics. Otherwise, ek patta bhi nahi hilega. So things are, the only thing is that these 3 are talking about energy science. Overall, this is energy science. Some utility function is getting maximized or minimized. That is very important. I tell you these things in my class also. When I go to the shop and I purchase a product, I am getting a product, somebody is getting a money. So some utility function is maximized for both of us. In nature, it is entropy and or maximization of entropy or minimization of free energy. The same thing you do when you do Shannon theory of information theory, where you maximize the entropy, where entropy is synonymous to the information you have. So basically everything is linked. If you see, the thermodynamic gives you a plethora of things which can be applied to information theory, to the technology, to science, everywhere. So we did the calculation. We see which kind of solvents we make, which can stabilize both the small product and a very big chain lignin. Then we figure out thermodynamics gives us a solution that is 60-40, 50-50 water and THF. This THF is a green solvent which can be regenerated through biological means. So you can generate a case where both can be stabilized. So my lignin is stabilized, my glycol is stabilized. But I told I cannot fully open the chain. If I fully open, it will be devastating consequence. If I don't open, then it will not be there. So what will happen? This thing we have taken, this 60-40 case, we have figured out that is giving a theta solvent. A theta solvent is something where chain is neither fully open nor fully closed. So we made the chain partially opened like this, where it will be a controlled chemical scissors are going and control way it is cutting the chains and giving me the products. So this is avoided, and this is there in the same solvent. My small molecule is also stabilized, and our molecule is well chosen because we have given a right target, which is also saving productivity in terms of time. So all these things, when we put together, we did experimental design, and finally we made the mechanisms, how the things are coming on this, and we finally get the glycol. And glycol, we do a separate transformation to phenol, which is a platform chemical. So after that, a lot of research happened. We have done PPD, basically 3.5 years of research. We could have published in many 3, 4, or 5 journal articles. We didn't do this. We waited 3.5 years to understand the process and to get this thing, because this problem is a grand challenge. And then after all these things, we made it published in the Green Chemistry, which is one of the best journal after Nature in this field. Okay, the environment and all this field. And this is Green Chemistry we have published. And not only that, our technology development project was a very big success. And you can see our performance with respect to the other one. This is a Nature publication, which looked at the world's best standard as of now. See what they have done. They are using 24 hours. The loading of lignin is too less. They use the solvent is much higher. This is one of the best. You see our case, we are using in only 2 hours. Our conversion is much higher. Okay, and we use much less solvent compared to them, and we are using high lignin things. So in any way, today's world, if you ask me, to most of my humble statement is that we are better than any standard being produced till date. And that too, we are very realistic. We have used only 260 degrees centigrade. We have used inert atmosphere, so which is very pretty standard. We have used green solvent. So if all these cases, if you see, it is one of the most practical solution we have offered to the world, right? And presently we are still working on this because science has no end, to sharpening more and more on this. And this is all about my work today. Please have a question if you have any.
Thank you, Professor, for an interesting and motivating talk. If there are questions from the audience, I'll take up some questions.
Hello, sir. This is Diksha.
Yeah, please go ahead.
So, just out of curiosity, do you work with other natural polymers also, like cellulose, chitin? Like
Yeah.
on the same
We
ground?
work in. Yeah, my another work is on drug delivery. Okay, biomaterial development. Okay, so we work a lot in the natural polymers like gelatin. We work. Okay, so biopolymers. I'm not saying natural polymers. Natural polymers, lignin only I work. Biopolymers, I'm working on gelatin with sodium alginates and chitosan. All these polymers also we work. And another natural polymer I work, as I mentioned, with Tata Steel, that is coal.
Okay, sir. Thank you.
Any other question from your side?
So if there are no questions, then let's thank the speaker for the session. Thank you, sir. I hope your insightful perspectives from the industrial side would help our researchers to solve the industrial problems. So once again, I thank you for an inspiring lecture. Thank you, sir.
Thank you very much. Thank you all for giving me the opportunity. Thanks a lot.
Yeah, thank
Bye.
you, sir, for taking your time.
Thank you.
You are very
Bye.
busy today.
Yeah, no, this
Yeah.
okay. We are always busy. Everybody is busy today, so we no, but then it's life. Okay,
Yeah.
thank you very much.
Yeah.
Thanks for
Yeah,
all of
thank
you
you,
to
sir.
take this beautiful initiative in this time of COVID. All positivities around these programs, and thanks a lot for your initiatives. Thanks a lot. Bye.
Thank you, sir.
Bye.
Thank you, sir.
Bye, sir.